This week, we want to talk about rational expressions. Remember that again, you do have quizzes due. Please check your due dates for everything that you need to have completed on time. Now, when we're talking about rational expressions, we're going to start with polynomials. P and Q are polynomials. Those are those expressions we've been working with. They contain a variable, quite often x, but they could contain any variable. If we have polynomials, P and Q, we could say that a rational expression is written as P divided by Q. Now remember what you know about fractions. We know that the denominator, in this case Q, cannot equal 0. So just like fractions, the denominator cannot equal 0. And any value of x that makes the denominator equal 0 is known as a restriction. Or we call them non-permissible values. Let me remind all of you again that you should have these notes printed and fill them in as you're listening to the lectures. If you don't have them printed, you should be writing this all down so you have notes to use when you revise for the final exam. So one of the things we want to talk about is finding our non-permissible values. You will often be asked to find any numbers for which each expression is undefined. Excuse me, let's go back here. Remember, if the denominator equals 0, then we would say that P over Q is undefined. So when we're asked to find numbers for which the expression is undefined, we're looking at the denominator. We're going to say that the denominator cannot equal 0. Find the non-permissible values of x, or find the restrictions. So we're looking at the denominator. We know that the denominator cannot equal 0. That tells us, if we add 2 to both sides, that x cannot equal 2. 2 is the non-permissible value. And we can see that when we check. If we substitute in x equals 2, we end up with 5 over 0. This is undefined. We don't want our expression to be undefined. Now, sometimes, though, people forget what I'm saying here, and they look at the numerator, and they say, oh, wait a minute, x cannot equal -3. Well, let's check that. If x is -3 and we substitute that in, oops, that's a -3 plus 3, we end up with 0 over -5. What does this equal? That's right, this equals 0. That's not a problem. The numerator is allowed to equal 0. We are only looking at the denominator. The denominator cannot equal 0. Let's look at question 2. The denominator cannot equal 0. We practiced last week solving quadratic equations. Why don't you pause your video and factor this? So again, using that zero factor theorem, we can say that x minus 7, instead of equal 0, it cannot equal 0. We're looking for the restrictions. We're looking for the non-permissible values. And we see that x cannot equal 7 and x cannot equal -2. Pause your video and find the non-permissible values for the next two. We're looking at the denominator. X cannot equal -3. We're looking at the denominator. 5 plus x squared cannot equal 0. Subtract 5 from both sides. X squared cannot equal -5. Now, I hope you're already thinking if I square x and x is a real number, it's never going to equal -5. And in fact, if we take the square root of both sides, we have the square root of a negative number. This tells me there are no restrictions. There are no restrictions if we have a sum of squares in the denominator. Now, 5 isn't exactly a square, but we could write this as the square root of 5. Let's pause there for this video.